Okay. So if you have not done so, if you have not done so, something to write with, periodic table, the 3 sheets from yesterday, calculate.
Oh, we can't talk.
All right. Yesterday, we went through and we introduced the concept of formula mass, and that will become apparent. Maybe not today why we did that, but probably tomorrow. Okay. But I did record classes today, so you can pretty class formula mass. Today, we are going to introduce the basic ideas of stoichiometry. Talk about what stoichiometry is, why do we do it, and then go through some basics as far as the real basic intro stuff. Tomorrow, we're back on lab. Okay. I think I explained to you the other day that the lab is a little bit, we have to do some things, then there's some downtime, and then we can do some things at the end. So in the middle section, we'll continue on with some stoichiometry ideas, continue developing it. You see, we'll start real simple, and we'll obviously increase degree of difficulty, so we'll go from there. Okay. Then Friday, we'll pretty much post-lab what we did in lab on Wednesday, introduce another kind of stoichiometry problem. We'll see how far we get on Wednesday, obviously. The quiz right now, still scheduled for Friday, but we'll see how far we get today, tomorrow, and then we'll get moving it if we need to. Then, next week, you guys are off Monday and Tuesday. Wednesday, we come back. We'll finish up stoichiometry stuff on Wednesday. I'll devote Thursday to reviewing, and then Friday test over all of the chemical reactions due to the process. Objective sheet is not posted yet. It's a pretty long objective sheet. It goes all the way back to like balancing equations and stuff like that. So it's kind of a lot. So I'll try and get that posted sometime in the near future here, so you can start looking at those things if you want to. All right. Questions about the calendar? Yesterday, we started talking about the idea of formula mass and how we start looking at counting the number of formula units or molecules that exist for compounds, just like we used to count the number of atoms in a sample. And we said that a lot of that was based off of these 3 equalities, which aren't shown very well, but I'll get them anyway. They'll show up more if you're watching the recording at home. So we said that there are 3 things that were equal to each other. First, we know that 1 mole of something is equal to 6.022 times 10 to the 23rd. That relationship holds true for everything. But now we changed the relationship for counting atoms. We said that 1 mole of something used to be equal to 6.022 times 10 to the 23rd atoms. But now it's equal to formula units. Okay? But then we said that that also is equal to the formula mass. How did we get the formula mass for a compound? What did we do? It's the molar mass, but it's the molar mass of what? Of all the things that are in that compound. Okay? So, off of this sheet, okay, the sheet that we were working off of yesterday, if yesterday I believe we filled out numbers 1 through 6, is that correct? Okay. Then 7 through 12 right here, okay? 7 through 12 we did not do. So to make this go a little faster, okay, there's the formulas for 7 through 12. So why don't you just go ahead and like write them down. Those are just the formulas for 7 through 12. Right? So right now, just write the formulas for 7 through 12. Okay?
Oh, I was looking.
Oh, there it is. Alright, so there's your formulas for 7 through 12. Okay.
Can you bold it?
What?
I can't really see it.
Let's see if this works. Is that better?
Yeah. What's the outside of the hydroxide?
2. It's the 2 over here.
What grade is your daughter in?
NH.
Oh, in preschool?
NH4. Yeah, she's pretty cool.
No, that you said your daughter. Yeah, does she have any, what color hair is she?
Brown. blonde hair, blue eyes.
Oh, that's weird. It's the genes. Does your wife have?
No, my sister has blonde hair, blue eyes, and her sister has red hair and blue eyes.
So the next baby's probably gonna have red. I realize.
Hey, do we have any formulas written down here?
Yeah, we do.
Can you bring a picture of them?
All right.
Like your Christmas card. Do you play Christmas?
Next, hey, the next thing I want you to do, I would like you to calculate for me the formula mass. Calculate for me the formula mass for number 7 and number 8. Calculate for me the formula mass for number 7 and number 8. You got that already. So, like you said, formula mass. How do we calculate the formula mass for something?
It's the
Add up the average atomic mass of all the atoms that are in that compound. For nitrate, this is down. It has 1 nitrogen and 3 oxygens. Well, O3 is just 3 oxygens, right? So yeah, so here. If we're looking at the formula mass for those two compounds, right? Lithium nitrate has 1 lithium, 1 nitrogen, and 3 oxygens. Yep, just add all those up. And then like ammonium chloride has 1 nitrogen, 4 hydrogens, and 1 chlorine. Okay.
Wait, what's number 7? It's LINO.
LINO.
What is it?
That's the formula, right? Did you write the formula down?
I wrote that.
Okay. So that means that those are three elements, right? Lithium, nitrogen, and oxygen. And there's 1 lithium, 1 nitrogen, and 3 oxygens in that compound.
Nitrate is
NO3, the group of 1 nitrogen and 3 oxygens that are together. It's one of those polyatomic ions, right? That sound familiar? Oh, if you are like hundreds off, like what did you get?
I got 68.95.
Yeah, that's fine. I was using a different periodic table. So.
The other one I had 53.
Yeah. Number 7 and number 8.
68.95.
Yeah, it should be okay. That's fine. Just your periodic table.
What?
What?
68.95.
Yeah. If you're like hundredths off, like in the hundredths place, we're just using different periodic tables. That's all. So. All right. Are we good with these two formula masses?
No.
See where we got these from?
Hold on.
Can we answer like 53.50?
Yeah, that'd be fine, Durant, yes. We just use different periodic tables, that's all.
So what is that for number NHCl?
What's the formula for number 8? What did you write down?
NH4Cl.
So how
So
many?
1 nitrogen, 4 hydrogen, 1 chlorine.
There you go. There you go.
If I still remember correctly,
If you've got the formula mass, you kind of see where this is going. On the back, I would like you to do number 19. Okay, number 19, which deals with the lithium nitrate. And then number 22. Number 22 is the ammonium chloride one. Actually, what do I want to do? 22 is the ammonium chloride one, but I wanted to do 23. That whole sheet, I just wanted you to do the six that we did yesterday. So, appreciate that formulas for the other 6. Maybe you could have 19 and 23. Yes, sir. The ones in the middle section, 7 through 12, they have polyatomic ions, right? The binary ionic compounds are just 1 metal and 1 non-metal, right? Does that sound somewhat familiar? nitrates and the sulfates. They're a group of atoms that act collectively as one like unit. So they'll form compounds together as a group. Okay. Yes? You get these numbers?
Yeah. Wait, oh, we're
For the
number
next
7 and 8.
Okay. So for number 19, okay, if you're already doing it, just continue on. If not, I'll go up here. Okay. So for number 19, we start off with our measurement with bad units, right? Time sign, fraction bar. We're going to put grams of lithium nitrate on the bottom. And then we're going to put moles of lithium nitrate on the top. So we talked yesterday about the 3 equalities that we use for compounds, right? What number always goes in front of moles?
1.
1 still always goes in front of moles. Then, for grams, what number goes in front of grams? The formula mass, right? So the formula mass that I calculated for lithium nitrate is right here. I think you guys got 68.95, whatever it is. But that goes in front of grams, right? Then it's just math. Grams lithium nitrate on the top, grams lithium nitrate on the bottom. That cancels out. You run it through your calculator, and 8.9477. Yep. 8.9477 moles lithium nitrate. Do I need all those digits?
Yes.
Yes. In the original number, 5 significant digits, 5 significant digits. Good.
We're gonna have to do some tests, and then under the tests, do we need to label those like parts of the process?
No, really, I'm just worried about the unit. Yeah.
So we won't get this off.
All right, let's do this last one, and then we'll move on. Okay. So for 23, okay, it says how many formula units are in 22.4 moles of aluminum phosphide? Aluminum phosphide is ALP, which is one of the ones from yesterday. Did we do this one yesterday? No, we didn't do it. But
I think it's been 22. Right?
okay, that's okay. Here, this one. There's a reason why I picked this one. So we start off with our bad unit with bad measurements, right? 22.4 moles of aluminum phosphide. Then, time sign, fraction bar. Moles of aluminum phosphide on the bottom. Then, formula units of aluminum phosphide on the top. Right? Because that's what this question is asking for. What number always goes in front of moles? 1 always goes in front of moles. And now, we've changed this from atoms to formula units,
That's 10 to the 23rd.
but it's still the same number. It's still Avogadro's number, 6.022 times 10 to the 23rd. Does it matter that this problem specifically lists aluminum phosphide as what we're trying to find the formula units of? Right? The answer to this problem would be the same no matter if we had aluminum phosphide or sodium chloride or whatever. Okay? Because formula units and moles, same number of things no matter what. Okay? So, moles, right? You run it through your calculator, and you end up with...
Does iPod Touch have like a good calculator on it?
Yeah. 1.25 times 10 to the 25th. 1.35 times 10 to the 25th. Yes, sir.
Can you help me? I forget which button you have to press.
Is there an E or an E button?
I know you have to press something on the second. If you press that, can you press the comma? So
Yeah, press second, yeah. All right, are we good here?
Yeah.
Okay. Let's put that sheet away. And then the one of the other sheets I gave you yesterday was the not the problem one, the PowerPoint. Yes. Yep, the one that has the slides on it.
Our comments is our whatever has something to do with formula.
The answers are online. I put the yeah, the answers to that whole sheet are online also. All right. Sorry, buddy. Yep. All right. Let's get started on the next part. The next part deals with stoichiometry. So,
In the commercial is a lady's like, hi, I'm something Deutsch.
I'm
I'm
Deutsch.
Ronnie Deutsch. That's the best.
All right. Stoichiometry, like the, and I realize that the background is pretty boring, so we're not going to be looking at too many slides. We're going to be doing more problems than looking at slides. All right. What we're doing in stoichiometry is we are looking at mass and quantity relationships among reactants and products in a chemical reaction. Earlier in this unit, we looked at the relationship between reactants and products in order to determine what kind of a reaction was happening. Right? If we looked at an equation and it was something small in the reactants and then something more complex in the products, we looked at that and went, okay, that's a synthesis reaction. Okay? Or if we started off with an element and a compound, and then we ended up in the products with a different element and a different compound, we would classify that, okay, that's a single replacement reaction. So there we're looking qualitatively at the relationship between reactants and products. What's there now, what's there next? Now we're going to start looking quantitatively. So we're going to start looking at numbers. How much of this reactant is there? How much product do we get out of that? So that's really what stoichiometry is all about. Stoichiometry deals with quantities of substances involved in chemical reaction. Okay? But there is a very important process that we go through, and that process is based off of the balanced chemical equation, and more specifically, the coefficients in the balanced chemical equation. For example, here is an equation that shows the reaction between nitrogen and hydrogen to form ammonia, which is the NH3 compound of the product side. Is that a balanced equation the way it is written right there? No. It is not. Okay? In order to balance that equation, we do this, which will hopefully show up here in a second.
No.
There it is. Okay. There's our balanced chemical equation for this reaction. Okay? I want you to take 15 seconds to talk to the person next to you and tell me, what does that equation say to you? What information are we conveying with that balanced chemical equation? Talk.
And when you put two nitrogen and three hydrogen, when you put two nitrogen and six hydrogen atoms together, you're going to get 6 molecules of nitrogen hydroxide and also hydrogen peroxide.
No.
So basically, it means that putting together nitrogen, two nitrogen.
What? Yeah, second. What is the second one?
You're getting 2 molecules.
All right, let's discuss. So, how many of us discussed that this bottom equation is telling you that 1 molecule of nitrogen is reacting with 3 molecules of hydrogen to produce 2 molecules of ammonia?
No, that's exactly
Was that really for real?
Okay, well, I
For real,
didn't
that's
say
exactly
that
what I said. Witnesses.
I did hear you say that.
I got to the point.
So, are we okay? Are we okay?
What do you mean?
So, does that make sense? That is what the balanced equation is telling you?
Yes.
Okay. Now, in real life, can we see the reaction between 1 molecule of nitrogen, 3 molecules of hydrogen, and 2 molecules of ammonia? No, it's way too small. Okay? But there is a way that we go from that small atomic world into our big macroscopic world where we measure things, right? And what is that way that we go from the small world to the big world? Even with a microscope, you can't see.
Macroscopes.
Yes. And more specifically, how much more of it? Yes, a lot more. Anyone? Like, how?
That's what I said.
Okay.
What?
Okay.
What was
So,
the
when we were counting atoms, right, we said we can't really count how many atoms are in a sample, right? But we talked about the idea that if we weigh out a sample equal to the average atomic mass, we know that there is a certain number of atoms there. How many atoms to be specific? 6.022 times 10 to the 23rd. That's a mole. A mole, the number of things in a mole is the same regardless of what it is that we're counting. So whereas this equation could say 1 molecule of nitrogen plus 3 molecules of hydrogen equals 2 molecules of ammonia, it could also tell you that 1 mole of nitrogen plus 3 moles of hydrogen gives you 2 moles of ammonia. Knowing what we know about math and formula mass and all those things, could we measure out a mole of nitrogen? Yeah. Can you measure out 3 moles of hydrogen? Yeah. And then you could make 2 moles of ammonia. So we have those coefficients on the balanced equation tell you the relationship between the number of molecules, but it also tells you the relationship between the number of moles, and that's important. Okay? Good there?
Yeah.
All right. So let's jump right into this.
I just need to do like examples.
Yeah, here we go. All right. So, example. As far as doing a stoichiometry problem, this is what we're going to do. Okay? First thing we're going to do, here, let me cut this out. Steps we're going to follow. Given the moles of one reactant product, we're going to calculate the moles of something else in that reaction. First, every stoichiometry problem has to start with a balanced chemical equation. It's got to be the first step. And for a reason that we'll talk about in a second. Then, it becomes a conversion problem. So we write the moles of what we want to get rid of, the given reactant and product. Then we set up a conversion factor to get us what we're looking for, the desired reactant or product. And we'll go through the steps to do that right now. Okay? Start off with the chemical equation. Then, number 2, what are we trying to get rid of? 3, a conversion factor to get what we want. That's how it works. That's why we do the conversion factor. So, let's go here, and let's take a look at, where am I? There. Then, go there. Come on. Come on. There we go. All right. Like it says up at the top of that next of the next slide, first stoichiometry problem. This one you might want to put like in your scrapbook, maybe something. You know. So it says, in a space station, carbon dioxide exhaled by astronauts can be removed by a reaction with lithium hydroxide. It says this reaction produces both lithium carbonate, which is Li2CO3, and liquid water. So that's kind of convenient, right? Because if we get rid of carbon dioxide in the air and we end up producing water, that's, you know, like recycling of resources and things like that. You know, those guys are pretty smart.
Yeah.
So, all right. So the first stoichiometry problem says how many moles of lithium hydroxide would be needed to remove 20 moles of carbon dioxide, which is the average daily amount. So how many moles of lithium hydroxide do we need to get rid of how much carbon dioxide we put out in a day? So, the first step in this process, we said the first thing we had to do was what?
Balanced equation.
Balanced equation. Okay? So, what are the reactants for this reaction?
Lithium
Okay?
hydroxide.
So, CO2, right? Nick is reacting with what?
Lithium hydroxide.
Lithium hydroxide, which I will tell you
Li2.
is LiOH. Okay?
Hydroxide, there's one. Well, hold on, how do we know
I would give that to you.
And then that would go
Okay.
What did we say the products of this reaction were?
lithium
Lithium
carbonate
carbonate
and liquid water.
And liquid water. So the first step, balanced chemical equation, is this equation balanced as written?
No.
Figure it out. Balance out.
Sure.
It's actually a pretty easy equation to balance. It's actually pretty easy to balance.
So that is. Water, you need to, there's a water only coming to. What about the CO? Oh, sorry, I can't. Oh, there's nothing else is the same.
What?
Right?
Is it balanced now?
Yeah.
It is. Okay. So I need balance.
Is that because the reactions are different? So,
Remember balancing equations, right? We have to have the same number of things over here as we do
yeah,
over there.
but there's like no other.
Right, but it's not. You're not looking for CO2s, right? We're looking for C and O and Li, right, and H. So we balance it according to each element.
Wait, but there's a CO2 there and then a CO3 here.
Yeah, but there's a C here and 2 oxygens here and 2 oxygens here, so there's 4 oxygens over here. Here's the balanced equation. Alright, so first thing, balanced equation. Next thing we do, it's a conversion problem from this point forward. So what are we trying to get rid of? What did we say is the reactant, one of our things here in this reaction?
CO2.
We're trying to get rid of this carbon dioxide. More specifically, 20 moles of carbon dioxide. Yeah, because if carbon dioxide levels get too high, then you're not breathing in carbon dioxide.
Carbon dioxide, which one's worse, carbon dioxide or monoxide?
Carbon monoxide is more dangerous to you, but you
Okay.
produce more carbon dioxide.
Okay.
So.
But
All right. So we start off with writing. This is just a conversion problem, right? So we start off writing the thing we're trying to get rid of. In this case, 20 moles of carbon dioxide. So then, the next step in a conversion problem is what? Times time fraction bar. Okay. Now, more specifically, Sam, and now this is where it has to get a little bit, and this is where it has to get a little bit more specific. Okay. Moles of what has to go on the bottom here? Okay. Moles of CO2 goes on the bottom because, Sam, what are we trying to get rid of here? We're trying to get rid of moles of CO2. What's the answer that we're looking for here? It says how many moles of lithium hydroxide. So a conversion factor is supposed to get rid of the stuff we want to get rid of and leave us with the stuff that we want. So what's going to go on the top there? Okay. It's going to be mole again, but it's not mole of CO2. Now it's mole of lithium hydroxide. Okay. This is the most important step when we're doing stoichiometry problems. Okay. So if we look, we refer to this step here as the mole ratio. Because it's a ratio of the moles of one thing in this reaction to another thing in that reaction.
Is it always going to be, like, are these questions, like,
No, this is the simplest one, but this step is always going to be in there. Because if we're going to compare one part of an equation to another part of an equation, we have to do it moles to moles. Okay? how did we compare moles to moles in that initial reaction, the nitrogen and hydrogen one that I gave you before? What did we say that this equation told us?
2 moles, no, 1 mole of
1 mole of nitrogen plus 3 moles of hydrogen, 2 moles there. So when you're setting up this conversion factor that has moles of one thing and moles of something else, where do the numbers come from? They come from the balanced equation, more specifically, which part of the balanced equation? Well,
The product. The coefficient.
the coefficients of the balanced equation. So what's the coefficient that's in front of carbon dioxide? 1 is in front of carbon dioxide. Right? What's the coefficient that's in front of lithium hydroxide? 2.
Why is it 2?
Because it's 2
Oh,
more.
okay, fine.
Because there is, right?
So it's 40.
So, in this case, right, this reaction tells us that 1 molecule of carbon dioxide plus 2 molecules of lithium hydroxide are necessary to make this go. 1 mole of carbon dioxide plus 2 moles of lithium hydroxide are required to make this reaction go. If I have 20 moles of carbon dioxide, how much lithium hydroxide am I going to need?
40.
Twice as much, right? Which just so happens to be 40. Here, if we do this conversion factor problem that we have set up, does the answer come out to be 40? It does, right? Here, moles of carbon dioxide on the top, moles of carbon dioxide on the bottom. Can I cancel these two? Can I cancel this one and this one? No, because this is moles of carbon dioxide, and that's moles of lithium hydroxide. It's not the same thing. No. It's the different coefficients. 1 mole of carbon dioxide and 1 mole of lithium hydroxide have the same number of things in them, but that's not what right here. So when we go through this, right, we end up with 40 moles of lithium hydroxide. Hold on a second, hold on. This sheet that I gave you yesterday, up at the top, it says mole-mole relationships. This goes through those kinds of problems that we just introduced. It's your first kind of stoichiometry problem called relationship between moles and moles. Okay? There are 3 problems on this sheet, a whopping 3 problems. Answers are online.
Why do you make us do this?
Take a look at those tonight. We'll come back tomorrow. You only have
Dude, it's so great. So like,